Hello and welcome. This week we'll just look at lessons 11 and 12. And again, we've seen these before. These are while loops. So these are sort of loops that will keep going and going and going until a condition is not true. Similar to a for loop, except the for loop we can control usually how many times it runs through. A while loop is very good if we just need to keep running and we don't know when it's going to end based on sort of a condition. And then we talk a little bit about what a loop, how you could use these loops for a simulation. So just to take a little look at the notes here, again, nothing beyond what you haven't learned before, right? So the while loop is a very simple loop simply because there's not that built-in sort of counter or whatever going on there. The biggest issue, of course, with a while loop is that there is the potential for it to go into an infinite loop. So if you said while true, it's in an infinite loop. If you've got while, the lives are greater than 0, well, if the lives never go down, it's in an infinite loop, right? So you always have to be a little bit more careful with that because there isn't a sort of a built-in timer. You can put that timer in or that built-in counter with no problem, but it just does create the potential to have that infinite loop. So you can look through this, right? Take out a pen and blank piece of paper. Are there fewer than 5 tallies on your paper? While that's true, continue to tally, right? Once you get to 5, you can put your pen down. So as long as you've got that counter working and there's potential for the tallies to go up, then this will keep going. You won't get an infinite loop because once that's done, it will jump out of it, okay? So it says, how is this flowchart similar to a normal conditional or if statement? Well, it has a Boolean expression, right? They're checking to see, right? In a certain way, if or while is kind of doing the same idea. If there are 5 and so on, there's some sort of condition that needs to be met, right? How is it different? Well, we can see that we've got the potential for this to run a number of times. And if and else would only have one possibility. Right. So that's just sort of, again, don't understand something, right? This loop, you keep having to review if you're using a while loop. And then once you finally understand it, hopefully, you can get a good night's sleep. Pretty straightforward. Another one here with a counter, okay? So this one is acting basically like a for loop, right? You've got a counter. While the counter is less than 5, it will keep running this. We've got the counter increasing as it says hi, and then it will jump out, okay? This case, you have to be careful, the potential to get that infinite loop. So it says, while the counter does not equal 10, well, here the counter is going up by 3. So you'd have 0, 3, 6, 9, 12. You're going to skip 10, so it's going to keep on going. It will never say done. Okay, so just be wary of that. Another issue that happens is that it never does this loop if you put the wrong thing in. Like if I said, while the counter is greater than 10. Well, if the counter is 0, it just never runs this because that's never true. So you always have to be careful of that. The infinite loop or your loop never runs. I think that's also an issue that comes up quite a bit. Okay, so we already know this vocabulary, so we just talked about the while loop, the counters, right? Something like this to be a counter, iteration, to iterate, to go through the loop, and the worry about an infinite loop. Now down here, it's just the idea of how you can use these loops to model real-world situations or make a simulation. And I won't really get into this because it's just modeling coin flips, which are pretty straightforward. But I really want you to, consider, again, how important computer science is to all the other sciences. I mean, you could talk about economics, you could talk about biology, you can talk about, a variety of subject matter where you need to do simulations, right? So it says weather, stock market, viral outbreak. I mean, this was written a few years ago. But all of these models require computers nowadays. We don't model anything by hand. They're all very, very complex programs, algorithms, based on data that sort of feed data into it, and then we sort of try to make predictions based on it. Are they 100% accurate? No, but over time, right? Once we can understand how this outbreak has occurred, we can take the real data, and then now our models are that much better. So it's always a matter of creating an initial model and then iterating on that to create something that's much more accurate as you move forward. So yeah, I mean, that's why, I think at the beginning of the year we talked about how, computer science is really in everything. If you're planning to go into medicine, don't discredit computer science, because everything in medicine has a computer background. Being able to talk to the patient and stuff, that's where the human component is, and that's what's really important, just like teaching too, right? That's the human part where we can make these connections with people and make things, real and substantial and meaningful. But behind the scenes, we need the data, we need the computer simulations to give us that information to make those decisions that are best for everyone. So, and that's not to say that computer models are infallible, and I don't want to put that impression on you, but it does give us a lot of information, and perhaps more so than what we could just do in our brains, right? Being able to just sort of make predictions with the model we've got, with all this data, we can make more accurate predictions, but they also are not infallible. So just keep that in mind. Anyways, I don't want to go on too long just talking about this, so please try to get through these 2 lessons. I think it's pretty straightforward, and just sort of think about the greater context. I mean, it's pretty simple what we're doing right now with coin flips, but this is sort of the basis of all those models that, predictive models that they've used for COVID-19 and so on. All right, talk to you later.